Despite sounding like the evil version of regular matter and energy, dark matter and dark energy occupy 95% of our universe, leaving us with only 5% for stuff that we see every day. They don't seem to interact with us at all, but they are some of the most important things that our universe needs to work the way it does. So in this video, we will explore what dark matter is, what dark energy is, why we know they are there, and the accelerating expansion of our universe. The idea of dark matter was first proposed when we found that gravity wasn't behaving like it's supposed to. Gravitational force attracts objects together, which gets stronger the more massive those objects are. When we observed galaxies, we noticed that with the amount of matter that we predicted, including black holes, stars, and planets, there shouldn't be enough gravitational force to hold everything together. Those space objects aren't massive enough to be orbiting in a galaxy. They should have been spun out. Furthermore, stars at the edge of the galaxy should be orbiting slower than the ones closer to the center, but they are all orbiting at the same speed. So we concluded that there must be some matter in those galaxies that gives them more mass so that the gravitational force will be stronger to hold everything together. This is how dark matter came to be. It simply is just matter that we cannot detect. This form of matter doesn't seem to interact with the electromagnetic force at all, which means that it doesn't reflect, emit, or radiate light that we can see. Our best theory is that it exists as a web-like structure that stretches across the entire universe, attracting the 5% of regular matter together with gravity. So if that's what dark matter means, is dark energy just energy that we can't see? Yeah, pretty much. Since gravitational force attracts objects together, then why isn't every single star in the universe just one big clump? There must be a force that pushes everything away from one another against gravity. As we looked into it, we have found that the universe is actually expanding faster than before, pulling us further from the other galaxies. We know this by looking at supernovae. When a massive star implodes, they emit a certain level of brightness that we can detect. However, the brightness of more recent supernovae appears to be dimmer, which means that they are further away than what we have predicted. The only explanation for this is an invisible energy that we cannot detect pushing against the gravitational force, forcing everything in our universe to move away from each other. And of course, since we can't detect it, we have dubbed this mysterious energy the dark energy. And there we have it. Despite only being able to detect 5% of our universe, we are still able to figure out the missing 95% of stuff that we can't see. Dark matter adds mass to the galaxies so that they can stay in orbit, while dark energy is a force that pushes us away from each other faster and faster. We have no idea what those things are made of. All we know is that they interact with gravity and don't react with anything else. But despite that, it's quite an impressive feat that us humans can discover something we literally cannot see. I hope that y'all have learned something interesting today. Thank you for your time and stay hydrated.